a tram. It rolls on rails and is powered by electricity, ensuring low friction with the surface and efficient operation. This is a bus. It can go almost anywhere, but it also consumes loads of gas and spews out tailpipe emissions. And this is a trolleybus. It combines the flexibility of buses with the clean, more efficient operation of electric power. Trolleybuses are, and have been, an integral part of many public transport systems around the world. In this video, we'll take a look at this mode of public transport, how it works, what are its advantages and disadvantages, and how they are coming back to cities which have ditched them in the 20th century. Before the bus looks quite similar to a normal diesel-powered bus, the only difference being the two trolley poles on the top. If you have ever seen a tram, you have probably noticed that they only have one wire, whereas trolleybuses have two. This is due to the fact that trolleybuses need two wires to complete an electrical circuit. Trams only need a single wire because they use the steel rails they run on as grounding. Even though buses and trolleybuses look similar, the internals of the vehicle are considerably different. First, depending on the type of bus, they only have a small diesel engine for backup purposes or have no conventional engine at all. Most modern trolleybuses have no conventional diesel engine, relying on electric motors powered by overhead wires for most of their trips and a small onboard battery for going off-wire. The battery is used for segments where wires can be installed or to avoid stuff like roadworks, car crashes, etc. Trolleybuses are also quieter than conventional buses because of their lack of combustion engines. Trolleybuses aren't the only way to electrify buses. Nowadays, there is a big debate going on about battery electric buses and trolleybuses. Some say that the added flexibility and lack of overhead wires of battery electric buses outweigh the negatives, like extra weight, higher purchase cost, and environmental damage from mining. Others say that the relative simplicity, lower purchase cost, and environmental friendliness of trolleybuses make them the superior choice. In my opinion, the answer lies somewhere in the middle. First, let's look at the costs of the vehicles themselves and their required infrastructure. Massive shout out to this article. In 2023, Toronto decided to order over 1,000 battery electric buses, but the fleet is still not fully electric. Full electrification is planned for the year 2040. There are three potential solutions for the full electrification of Toronto's buses. The first is using battery electric buses, which would get charged overnight in depots. The second proposal uses battery electric buses, which would get charged by overhead wires on portions of their routes, with some charging being done in depots. The final proposal is a traditional trolleybus system, with overhead wires on the vast majority of its routes. Let's take a look at all three of these proposals. If Toronto decided to go with the first proposal, 91 million Canadian dollars would have to be spent on charging infrastructure. Then, hundreds of millions of dollars would have to be spent on the buses themselves, with an individual cost of $1 million per bus, and $25 million would have to be spent to acquire the land needed for charging the vehicles. There are some less obvious costs as well. Since battery electric buses have to carry loads of batteries everywhere, they're very heavy vehicles. Because of another problem caused by the increased weight of battery electric buses is the fatality rate of crashes. The heavier the vehicles involved in a crash are, the more likely it is for someone to die from it. According to this paper, lastly, the huge batteries require loads of rare earth materials and elements like cobalt and nickel, which are sometimes mined in less than ideal conditions. However, this approach comes with some advantages. Firstly, I think it will be easier to implement, because NIMBYs won't scream about the overhead wires destroying the character of the neighborhood. Secondly, this approach grants the most route flexibility, allowing routes to be set up quickly and pretty much anywhere. And thirdly, the transit authority would have less infrastructure to maintain, because no overhead wires would have to be put up. Now, let's move on to the second proposal. Taking this approach would involve Toronto purchasing slightly less buses, and mostly charging them with portions of overhead wire on certain segments, like at the terminus stations of individual lines. This solution would cost the city 160 million Canadian dollars for charging infrastructure, hundreds of millions of dollars for vehicles, and $25 million for land acquisitions. Other than the method of charging, This approach isn't really different from the first one, as it relies on the same battery electric buses. Now, let's move on to the last proposal. The last proposal consists of building a full trolleybus network, with the vehicles attached to overhead wires for the vast majority of their journeys. This approach would cost Toronto $105.2 million Canadian dollars for the infrastructure, including wires, transformer stations, etc. The network would be able to operate with a smaller fleet of trolleybuses, because they wouldn't need to be charged, with a cost of $1.2 million per vehicle. Note that the increased cost of trolleybuses is likely due to the fact that North America doesn't really have trolleybuses, making manufacturing them more expensive, because there aren't economies of scale. Trolleybuses have a few advantages to battery electric buses. First, their lighter weight means that they cause less road wear, and that they cause less fatal crashes. Trolleybuses are also ideal for cities with lots of hills, because of their lower weight, as well as the electric motor's superior acceleration and instant engine torque. Now that we've looked at all bus electrification methods, let's look at an example of the implementation of trolleybuses happening right now. This is the city of Prague, Czech Republic, and this is its airport, called Václav Havel Airport. A train line is currently under construction, but until that happens, the only public transport connection to the wider city is with buses. For the majority of its existence, Line 119 has been served by articulated diesel buses. However, on the 6th of March 2024, this is about to change. On that day, Line 119 will cease to exist, and the trolleybus Line 59 will rise out of its ashes. Line 59 will be served by this double-articulated absolute unit of a trolleybus. Clocking in at almost 25 meters in length, this vehicle will provide much-needed additional capacity to the line. As a person who has taken this bus line a few times, it's completely overcrowded at peak hours. As for the electrification approach, the line will run on overhead wires on one half of its route, and the rest on battery power. There will be a charging station at each terminus of the line. In conclusion, buses can be electrified in different ways, be it running them completely on overhead wires, charging onboard batteries, or a mix of both. I believe that trolleybuses are a great method of transport, and they definitely have a place in 21st century cities. Anyway, thank you so much for watching to the end, you're a real legend. Let me know if you liked the video, enjoyed the bloopers. This has been Tramley, and I'll see you next time. Bye! In this video, we'll take a look at this mode of public transport, how it works, what are its... Some say that the added flexibility and lack of overhead wires of battery electric buses outweigh the negatives, like extra weight, higher purchase cost, and massive shoutout to the... Firstly, I think it will be easier to implement, because NIMBYs won't scream about... Now that we've looked at all bus electrification methods, let's look at an example of an...